Students and parents, hope you're doing good. Have a sheet of paper and pencils ready. These notes are to be copied onto a separate piece of lined paper. Follow along to find out what multiplication comparisons, that's a hard thing to say, multiplication comparisons are, and how we may use mathematics to compare the sizes of objects and situations we may come across. Watch the video a number of times until you understand and can summarize what is being said. Don't forget to take those notes on your own. This is a very difficult concept, multiplication comparisons. I'm going to try my best to explain it. So I just want you to take notes on this. So get a blank sheet of paper, pause the video, make sure you have, two sharp pencils. Two sharp pencils ready to go, and then come on back. For multiplication comparisons, we're just going to look at this part, this comparison part. What does that mean? So let's take something concrete to start out with, because we always go from concrete to more abstract. And let's see, so we need something that you're familiar with. How about bananas? Oh, Mr. Budinger, have you gone nuts? No, I've gone bananas. Now, if you were to look at these bananas, you would say, hey, Mr. Budinger, there's nothing different about these bananas. They're both the same. Same color, they taste the same, they're bananas. I'd say, okay. But how could we compare these bananas mathematically? And you'd be kind of curious about that. So let's satisfy that curiosity. Let's first say that you're right. Bananas, or let's just say in our example, one banana is equivalent to another banana. Okay, not a lot going on there. But if you noticed, there's something different about these bananas. This banana is larger, so it probably weighs more than this banana. So mathematically, we can compare these two identical bananas and say, well, one banana is 7 ounces, and the other banana is 5 ounces. And we can come up with two different numbers to compare these bananas. And that would be a way of explaining something that's identical mathematically, to kind of separate the two. That's a comparison. Now we can compare the two bananas, even something that's identical as bananas. Let's look at some geometry. We're going to get to geometry probably towards the end of the year. Let's look at these two shapes. They both have the same number of sides, so we can't compare them that way. They both have the same number of corners. Now, in geometry, we call these vertices, where corners meet. They have 4 angles, but their angles are different. These angles are called right angles. This angle here, if you remember from 3rd grade, is called obtuse because it's greater, this measurement is greater than the right angle. And this one here is called acute, which is, it's smaller, it's less than, there's less angle here than the right angle. And these two angles are identical, we kind of show that like this, and these two angles up here are identical. So now we've got a way of identifying these two shapes. We can say this shape has 4 right angles, and this one has 2 obtuse angles and 2 acute angles. So now we're taking something that looks similar and we're explaining in a way that shows we're comparing them, okay, in a way that shows that they're different. That's what we do using comparisons in math. Let's go to something now that you're familiar with. Let's use arrays. And let's set up, let's say these are Skittles because our dots represent something, some noun. And let's say this is you. Okay. And let's say this is me. Now in grades K, kindergarten, all the way to 3rd, you might have said, I have 12, and Mr. Budinger has 4. He would need 8 more Skittles to have the same amount, to be equal to my amount. Well, that's using addition. We're going to use multiplication. And we're going to use Mr. Budinger's three-number principle. Remember that? So let's go a little bit more abstract now. So our cloud has gone from concrete to abstract. And how would we write this out as an equation? Think of our short math statements and our equations in general. This one has the number 12, and this one has the number 4. We could use, say this, an example, an equation for this. We could say 12 is 3 times as many as 4. So this is 3 times greater than that. We're always going to go from smaller to larger in our comparisons in 4th grade. We can also write this as a short math statement. If you remember, this equal is kind of the is. 12 is 3 times as many as 4. So we're using multiplication instead of addition to compare amounts. And it's always a smaller amount to a larger amount. Let's look at our ribbon tape models, because you guys are now have some work with that. And we're getting more abstract as we go. So as we go down the page here, we're getting more abstract. Let's use a ribbon tape model. And let's say this is you and this is me. Okay. How would we explain this using a ribbon tape model? Think about that for a little bit. Pause the video if you need to. So for you, we know that you have 12 altogether. This would be your amount that you have of Skittles. And for me, we know I'd have 4. So how can we represent that 12 and 4 with the other parts of our equation? Because remember, we need 3 numbers. So think about where those numbers would go here. If you look at your equation here, and you see that we have 3 boxes, you could say, well, this is going to be 3 times the same amount here that's here. This would be 4. This is what I have in my circle here. This is 3 times that, and that's how we got to 12. So this would again be 12 is equal to 3 times as many as 4. This would be a representation of that as a ribbon model. And down here, well, I don't know what this would be. This would be like 4 is equal to 4, and up here I guess it'd be 1 times, or so this would be reversed then. This would be 4 1 times as many as 4, which is 4, and these two numbers are identical. So this doesn't make Mr. Buddinger's 3-number principal, and we'll talk about that. One has its own property that's important, but we'll look at that later on. Let's look at a ribbon model. Going this way, and we'll use this as our comparison. And let's make two identical ones, just like we had two identical bananas, okay? The ribbon model looks basically the same for each of these. And let's say these are two buildings, and whatever we measure in these two buildings, we're going to keep consistent like what we measured in our ribbon models here. So let's say these are buildings. And let's say this building down here, remember we're going from smaller to larger, we're measuring 2. This is going to be our unit of measurement as 2. What then is this building's size going to be if we're using a multiplication comparison? Well, we have to compare it to the same size here. How many times taller is it? Well, let's see. We'll just keep on stacking up our 2's. And we'll say 1, 2, 3, 4, 5, 6. This is 6 times, hold on here. This is 6 times that 2. And what would the product be for that? Well, that's relatively easy. If we took all these 2's that we stacked on top of each other and multiplied them times 6, that's going to equal 12. And the equation for this would be 12 is equal to 6 times 2. Now over here we have an identical model, but let's say what we're representing as our unit over here is 3. How is that going to change things? Even though they're identical models, what should we start putting in our boxes here? If you said 3, you're correct. How many times taller would this be than this over here? It'd still be 6 times taller. So this is kind of what the abstractness is. Even though this building looks taller, we're using a model that makes it look about the same size. Okay? So how tall would this building be if it was 6 times taller than this building over here? Well, what's 6 times 3? If you know your multiplication, like you should at this point, you would say it's 18. Now we haven't put in any other units in here other than just using the numbers. Okay? What would this equation be down here? I'm going to write it a little bit differently. I'm going to say 6 times 3 equals 18. Now both of these, we're using the same model, but we come up with something completely different in these examples. This is comparing something smaller to something larger. Not using addition, but using multiplication. Using multiplication. So we're always going from something smaller to something bigger, and we're saying, how much bigger is this? And we aren't using addition, we're using multiplication. This is 6 times taller than this. This was 2, so 6 times taller is going to be 12. This is 6 times taller than this. We use 3 here, so it's going to be 18. So 6 times taller than 3 is going to be 18. So this was a lot to understand. I hope this helps understand what a comparison is, and even better, what a multiplication comparison is. And if you need to view this video more than a couple times, please do so. I hope I blew your mind.